Hello, in this lecture we will find out the size of line segment AE. In the drawing we have square ABCD. We know that angle DEB or angle BED equals to 90 degrees. This angle equals to 90 degrees. It is a right angle. We also know that line segment BE equals to 2 units, line segment DE equals to 8 units, and we want to find out the size of line segment AE. So we actually want to find out the size of this line segment AE, the line segment in the red color. So first of all, we will join together points B and D by a straight line. BD is actually the diagonal of square ABCD, but actually triangle BED is a right triangle because this angle equals to 90 degrees. So I will write it down. Triangle BED is a right triangle I will repeat again, this triangle BED is a right triangle, so we can implement the Pythagorean theorem in the right triangle BED. So according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And in this right triangle DEB, the hypotenuse is BD, so the square of the hypotenuse is BD square. And it equals to the sum of the squares of the perpendiculars, that is to say, it will be equal to EB square plus DE square. I will repeat again. In the right triangle BED, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BD, so BD square equals to the sum of the squares of the perpendiculars equals to EB square plus DE square. So according to equation number 1, BD square equals to EB square. EB equals to 2 units. It is given us the question. So EB square is 2 square. 2 square is 4 plus DE square. DE equals to 8 units according to what is given us in the question. So DE square is 8 square. 8 square is 64. So in total we got that BD square equals to 64 plus 4 is 68. Here we will take a root of equation number 1 and we get that BD equals to the square root of 68. So we actually found out that the diagonal BD of DB equals to the square root of 68 units, and we also have the rule that all the angles inside the square are right angles, therefore this angle BCD will be a right angle, it equals to 90 degrees, and this angle BAD also will be a right angle, that is to say it equals to 90 degrees. In the next step I will present to you a new rule number 1. According to rule number 1, the diagonals of a square bisects or bisect the angles of the square into 45 degrees angles. So I will repeat on rule number 1 again. The diagonals of a square bisect or cross the angles of the square into 45 degrees angles. So the rule means that the diagonals of a square divides the angles of a square that they are all equals to 90 degrees. It divides it to two equal angles. So all the angles of the square are right angles, so therefore the diagonals of the square divides the angle of the square to 45 degrees angles. So, and we have here diagonal BD is the diagonal of square ABCD, therefore according to rule number 1, diagonal BD bisects this angle to 45 degrees. This angle will be equal to 45 degrees according to rule number 1, and this angle will be also equal to 45 degrees. Likewise, here the diagonal DB bisects this angle ABC, into two equal angles, so this angle will be equal to 45 degrees. This angle will be also equal to 45 degrees. Triangle PCD, this is triangle BCD is a right triangle because this angle equals to 90 degrees. So triangle BCD is the right triangle, triangle BCD. Cosinus 45 degrees equals to DC over DB. Cosinus 45 degrees equals to DC over DB. We will define side DC of the square as y, that is to say DC equals to y. So, and we know that dB equals to square root of 68. Therefore, DC equals to y according to our definition, and dB equals to the square root of 68. In total, we got that according to equation number 2, cosinus 45 degrees equals to y over square root of 68. We know that cosinus 45 degrees equals to square root of 2 over 2. So we substitute cosinus 45 degrees to square root of 2 over 2. And it equals to y over square root of 68. So here we will multiply equation number 2 by square root of 68, and we will get that square root of 2 over 2 times square root of 68 equals to y. So we multiply equation number 2 by square root of 68, and we got that y equals to the square root of 2 over 2 times square root of 68. We know that 68 is 34 times 2, so we'll substitute 68 by 34 times 2, and we'll get that y equals to the square root of 2 over 2 times square root of 2 times 34. We actually have a rule that states that square root of a times b equals to square root of a times square root of b. So according to this rule, square root of 2 times 34 will be equal to square root of 2 times square root of 34, and you multiply it by square root of 2 over 2. It equals to y according to equation number 2. Square root of 2 times square root of 2 is 2, so I write it down. y equals to square root of 2 times square root of 2 is 2 times square root of 34 over 2. 2 over 2 is 1, so 2 will get cancelled. And actually found out that y equals to square root of 34 units. So all the sides of square ABCD are equal to each other, and therefore all the sides of square ABCD will be equal to the square root of 34. Okay, so DC equals to square root of 34. Side BC of square ABCD equals to the square root of 34. Side AB of square ABCD equals to the square root of 34. And side DA of square ABCD equals to the square root of 34. Okay, so in the next step I will present to you new rule number 2. According to rule number 2, if a line segment AB subtends two equal angles, on the same side, then quadrilateral ABCD is inscribed by a circle and the 4 points A, B, C, and D lie on that circle. So I will read rule number 2 again. Rule number 2 states that if a line segment AB subtends two equal angles on the same side, then quadrilateral ABCD is inscribed by a circle and the 4 points A, B, C, and D lie on that circle. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have line segment AB So we have this line segment AB, and on this line segment AB we have two angles that rest on line segment AB. The first angle is angle angle HCB rests on line segment AB, and it equals to theta according to our definition. And we have a second angle that rests on the same line segment AB. And the second angle, angle ABB, also rests on some standard line segment AB. So if we have two equal angles that rest on the same line segment, like in this drawing, those two equal angles, they are both equal to theta, and they rest on the same line segment AB. Then, according to rule number 2, the quadrilateral ABCD, this quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. So the quadrilateral ABCD is inscribed by a circle, so quadrilateral ABCD, this quadrilateral is inscribed by this red circle, and the 4 points A, B, C, and D lie on this red circle. Okay, so as you can see from the drawing, quadrilateral ABCD is inscribed by this red circle, and the 4 points A, B, C, and D lie on this red circle. Okay, so this is the explanation of rule number 2. Whenever you have line segments AB and you have two equal angles that rest on that line segment, on the same line segment AB, then the quadrilateral ABCD is inscribed by this red circle, and the 4 points A, B, C, and D lie on this red circle. Okay, so you can actually implement rule number 2 in our drawing. Because in our drawing we have those two right angles. Angle DEB is a right angle and it subtends or rests on line segment DB. And also we have angle DAB, this angle that also rests on the same line segment DB. Therefore, so I will write it down. Angle BED that equals to 90 degrees rest on line segment BD this angle BD rests on line segment BD, and also we have a second angle DAB that also equals to 90 degrees. Rest on the same line segment DB. I will repeat again. Angle DEB that equals to 90 degrees rests on line segment DB, and angle DAB that also equals to 90 degrees also rests on the same line segment DB. Therefore, according to rule number 2, the quadrilateral AEBD, the quadrilateral AEDB so the quadrilateral AEDB is inscribed by a circle. Therefore, according to rule number 2, the quadrilateral AEBD is inscribed by a circle, and the 4 points A, B, C, the 4 points A, E, B, and D rest on that circle. I repeat again, because of the fact that those two right angles rest on the same segment line BD, therefore according to rule number 2, the quadrilateral AEBD, this quadrilateral in the green color, the quadrilateral that I paint in the green color is inscribed by a circle. This quadrilateral AEBD is inscribed by a circle, and the 4 points A, E, B, and D rest on that circle. Okay, so we have our quadrilateral AEBD is inscribed by this circle, so I will draw the quadrilateral AEBD in the green color is inscribed by a circle. So according to rule number 2, this quadrilateral AEBD in the red color is inscribed by this blue circle. I will paint it in the green color like this, like this quadrilateral. It's the same, exactly the same quadrilateral that is inscribed by this blue circle. So I repeat again, because of the fact that we have two right angles, those two right angles subtend on the same segment line DV. Therefore, according to rule number 2, this quadrilateral AEBD in the green color is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. This is actually the implementation of rule number 2 in our drawing. Okay, this is true according to rule number 2. So whenever you have a line segment, like in this example, like segment DB, and you have two equal angles that rest on that line segment DB or BD, then the quadrilateral AEBD is described by the red circle, by the blue circle, and the 4 points A, E, B, and D lie on this blue circle. Okay? This is the implementation of rule number 2 in our drawing. So in the next step I will present to you rule number 3, and we will implement rule number 3 in our drawing. Rule number 3 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So, I'll read rule number 3 again. Rule number 3 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So, what is the meaning of rule number 3? The meaning of rule number 3 is that if you have a quadrilateral ABCD that is described by this circle, so this right quadrilateral ABCD is described by this blue circle, quadrilateral ABCD has two diagonals. The first diagonal is diagonal AC, we will define diagonal AC as x, that is to say the size of diagonal AC is x units, and quadrilateral ABCD has also second diagonal DB, we will define diagonal DB as y, that is to say the size of diagonal DB equals to 8 y units. So according to rule number 3, whenever we have diagonal that is inscribed by a circle, like in this drawing, diagonal ABCD is inscribed by this blue circle, then according to rule number 3, the product of its diagonals is actually x times y. The product of its diagonals equals to the sum of the products of its opposite sides. Quadrilateral ABCD has two pairs of opposite sides. The first pair of opposite sides is AD. Side AD is opposite to side BC. And the second pair of opposite sides is actually side AB is opposite to side DC. And the first product of its opposite sides is but before that I will define the size of side AB as A units, the size of side BC is B units, BC equals to B units in its size, the size of side DC is C, DC equals to C units in its size, and the size of side AD is D, that is to say AD equals to D units in its size. So, according to rule number 3, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. As I already said, quadrilateral ABCD has two pairs of opposite sides. AD is opposite to BC and AB is opposite to CD. And the first product of its opposite sides is AD times BC, but AD equals to D units in its size and BC equals to B units in its size. So actually the product of its opposite sides is actually B times D. That is the first product of the opposite sides. And the second product of the opposite sides, it is actually A times C. Okay? And the sum of product of the opposite sides, it is actually BD plus AC. The sum of the product, the adding of the two products together will give us the sum of the products of the opposite sides. Sum 1 plus sum 2 equals to the sum, product 1 plus product 2 equals to the sum of the products of the two opposite sides. So BD plus AC is the sum of the product of the opposite sides, and it equals to the product of its diagonals, that is to say x times y. I repeat again, the product of its diagonals is x times y, and it equals to the sum of the products of its opposite sides, that is actually BD plus AC. Okay, so now we'll implement rule number 3 in our drawing. First of all, why rule number 3 apply to this drawing? Because in this drawing we have quadrilateral AEBD that is inscribed by a circle. Whenever you have quadrilateral that it is inscribed by a circle, you can implement rule number 3. And according to rule number 3, the product of quadrilateral AEBD diagonals, it is actually AB times DE, AB times DE, and the product of its diagonals equals to the sum of the products of its opposite sides. the first product of the opposite sides is AE times DB. And the second product of the opposite sides, it is actually AD times EB. And the sum of products of its opposite sides, it is actually the first product plus the second product. That is to say, it equals to AE times DB plus AD times EB. Okay, I'll repeat again. The product of its diagonals, the product of quadrilateral AEBD diagonals is AB times DE, and that product equals to the sum of the product of its opposite sides. And the sum of the product of its opposite sides, the first product is AE times DB, the second product of its opposite sides is AD times EB, and the sum of the product of its opposite sides is AE times DB plus AD times EB. The equation number 3 is the implementation of rule number 3 in our drawing. Okay, so the only thing that is left to do is to put the data inside this equation number 3, and then we'll find out the size of line segment AE that is also inside this equation number 3. Okay, so what is the size? I will copy again equation number 3 in this new page, and we will put the data inside this equation number 3. Okay, so AB times DE equals to AE times DB plus AD times EB. So I copied again equation number 3, and we will find out the values, that is the values of those variables that in equation number 3. First of all, what is AB? AB, from this domain we can see that AB equals to the square root of 34. Okay, so AB equals to the square root of 34. And what is DE? From the drawing we can see that DE equals to 8 units. It is giving us the question. DE equals to 8 units. And all equals to AE. AE is the missing line segment, so we will leave it as it is, times DB. What is DB? DB equals to the square root of 68. We have already found out that DB equals to the square root of 68 plus AD. What is AD? AD equals to the square root of 34. So we write down that AD equals to the square root of 34 times EB. What is EB? EB equals to 2 units according to what is given us in the question. Okay. So the only missing variable in this equation number 3 is AE. AE is the line segment that is missing. So here 68 is 34 times 2, so I will write it down. We'll substitute 68 by 34 times 2 plus square root of 34 times 2 it is multiplied by AE, that is the missing line segment that we are looking for, and all equals to square root of 34 times 8 . So here we have square root of 34 times 2, according to the rule that the square root of a times b equals to the square root of a times square root of b. The square root of 34 times 2 will be equal to the square root of 34 times square root of 2 plus square root of 34 times 2 times AE equals to square root of 34 times 8, and this is actually equation number 3. So here we will divide equation number 3 by square root of 34, and we will get that so square root of 34 will get cancelled, and what is left after we cancelled square root of 34? What is left, it is actually, here's 8 equals to square root of 2 times AE plus 2. So here we will subtract 2 from equation number 3, and we will get that 8 minus 2 is 6, so 6 equals to the square root of 2 times AE. Here we will divide equation number 3 by square root of 2, and we will get that the missing line segment that we are looking for, that is to say AE, equals to 6 over square root of 2 so here 6 is 3 times 2, so we'll substitute 6 by 3 times 2 in equation number 3. So we'll get that AE equals to 3 times 2 over square root of 2 we will multiply this expression by square root of 2, and then we will divide it by square root of 2, so we change nothing, so it is allowable to do it. In the denominator of this expression, we have square root of 2 times square root of 2, and square root of 2 times square root of 2 is 2. So I write it down, AE equals to 3 times 2 times square root of 2, and square root of 2 times square root of 2 is 2. So here 2 over 2 is 1, so 2 will get cancelled, and we actually found out that AE, the missing line segment that we are looking for, equals to 3 times square root of 2 units, or in terms of numbers, AE equals to 4 4.243 units. I will repeat again. The missing 9 segment AE equals to either 3 times root 2 units, or in terms of numbers, 9 segment AE equals to 4.243 units. That is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the size of this 9 segment AE. We have square ABCD, and we know that 9 segment EB equals to 2 units, 9 segment DE equals to 8 units. And we want to find out the size of 9 segment AE. We also know that angle BED equals to 90 degrees. So the first thing that we did is we actually joined together by a straight line points B and D. And actually triangle BED, this triangle is a right triangle because it has angle that equals to 90 degrees. So in the right triangle BED, according to the Pythagoras theorem, BD square equals to EB square plus DE square. So BD square equals to EB equals to 2 units. So EB square is 2 square is 4, plus DE square. DE equals to 8 units, it is given us the question. So DE square is 8 square is 64. And 4 plus 64 is 68, so we got that dB square equals to 68. So here we took a root out of equation number 1 and we got the value of dB. dB equals to the square root of 68 units. So here we can write that dB equals to the root of 68 units. dB, it is actually also the diagonal of square ABCD. Okay, and then I presented to you rule number 1. According to rule number 1, the diagonals of a square bisect or cross the angles of the square into 45 degrees angles. Okay, so we have here diagonal DB, and according to rule number 1, this diagonal DB bisects the angles of this square, those two angles, to 45 degrees. As you already know, all the angles inside the square are right angles. That is to say, they are equal to 90 degrees. So if the diagonal bisects the angle, it means that it divides it to 2 equal parts. And 90 degrees over 2 is 45 degrees. So according to rule number 1, this diagonal DB bisects the angles into this angle will be equal to 45 degrees, and this angle will be also equal to 45 degrees. Likewise here, the diagonal DB bisects the angle, that is to say this angle will be equal to 45 degrees, and this angle will be also equal to 45 degrees. and because of the fact that all the angles inside the square are right angles, this angle is right angle, and this angle is also a right angle, it equals to 90 degrees. So if we focus on the right triangle BDC, according, we know that here cosinus 45 degrees equals to DC over DB. Cosinus in the right triangle DCB, cosinus 45 degrees equals to DC over DB. Actually, we defined DC as Y. So, and we know that DB equals to the square root of 68. Therefore, we can substitute DC by Y and DB by square root of 68. So we got in total that cosinus 45 degrees equals to Y over square root of 68. But we also know that cosinus 45 degrees equals to the square root of 2 over 2. So we substituted cosinus 45 degrees by square root of 2 over 2. Here we multiplied equation number 2 by square root of 68, and we got that square root of 2 over 2 times square root of 68 equals to Y. We know that 68 is 2 times 34. So we substituted 68 by 2 times 34, and we got that Y equals to square root of 2 over 2 times the root of 2 times 34. We have the rule that the square root of A times B equals to the square root of A times square root of B. So according to this rule, the square root of 2 times 34 will be equal to the square root of 2 times square root of 34. Okay? So Y equals to the square root of 2 times square root of 2 times square root of 34 over 2. And square root of 2 times square root of 2 is 2. So we got here that Y equals to 2 times square root of 34 over 2. 2 over 2 is 1, so 2 will get cancelled, and we got that Y equals to the square root of 34 units. So this side, Y equals to the square root of 34, but because of the fact that all the sides of a square are equal to each other, therefore all the other sides of square ABCD will be equal to the square root of 34 units. So side BC equals to the square root of 34 units, side AB equals to the square root of 34 units, and side AD will be also equal to the square root of 34 units. Then I presented to you rule number 2. According to rule number 2, if line segment AB subtends 2 equal angles on the same side, then quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this line segment AB, and we have 2 equal angles that subtend on line segment AB. Of those 2 equal angles, they are both equal to theta, rest on the same line segment AB. Therefore, according to rule number 2, the quadrilateral ABCD, this quadrilateral is inscribed by this red circle, and all the 4 points A, B, C, and D lie on this red circle. So because of the fact that we have line segment AB and we have 2 equal angles that rest on line segment AB, therefore the quadrilateral ABCD is inscribed by this red circle, and the 4 points A, B, C, and D lie on this red circle. Okay, this is the explanation of rule number 2. And then we can implement rule number 2 in our drawing. Why we can implement rule number 2 in our drawing? Because in our drawing we have those two right angles. They are both rest on the same segment line DB. As you can see, this angle BED that equals to 90 degrees rests on line segment BD, and this angle PAD that also equals to 90 degrees rests on the same segment line BD. Therefore, according to rule number 2, the quadrilateral AEBD in the green color is inscribed by a circle, and the 4 points A, E, B, and D rest on that circle. Okay? So, because of the fact that we have two right angles that rest on the same segment line DB, therefore, according to rule number 2, the quadrilateral AEBD in the green color is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. So, whenever we have line segments and we have two equal angles that rest on that line segment on the same side, then the quadrilateral that was created by those two angles and the line segment, in this case it is quadrilateral AEBD, this quadrilateral will be inscribed by a circle, like in this drawing. Quadrilateral AEBD is inscribed by the blue circle, and the 4 points A, E, B, and D lie on this blue circle. Okay? I'll repeat again. If you have a line segment and two equal angles that rest on that line segment, then according to rule number 2, the quadrilateral that was created by those two angles and the line segment will be inscribed by a circle, and the 4 points, in this case is points A, E, B, and D, lie on that circle. Okay? And then I presented to you rule number 3, and then implemented rule number 3 in our drawing, in this drawing. So what is rule number 3? Rule number 3 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 3? The meaning of rule number 3 is that whenever you have quadrilateral, any quadrilateral, and a circle that blocks that quadrilateral, then you can implement rule number 3. So here we have quadrilateral ABCD and blue circle that describe this quadrilateral ABCD. Quadrilateral ABCD has two diagonals, diagonal AC. Diagonal AC is defined as X. That is to say the size of diagonal AC is X units. And also it has diagonal BD. Diagonal BD equals to Y. That is to say it equals to Y units in its size. And we also know that the size of side AB of quadrilateral ABCD is A units, the size of side BC of quadrilateral ABCD is B units, and the size of side CD of quadrilateral ABCD is C units, and the size of side AD of quadrilateral ABCD is D units. So according to rule number 3, whenever you have quadrilateral that is described by a circle like in this drawing, then the product of its diagonals, is X times Y, equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides, it is actually BD plus AC. Okay? Why? Because quadrilateral ABCD has two pairs of opposite sides. side AD is opposite to side BD, and the product of side AD with BC is actually B times D, and also quadrilateral ABCD is the second pair of opposite sides. Side AB is opposite to side CD, and the product of the second opposite sides, it is actually A times D, and the sum of the product of the two opposite sides, it is actually BD plus AC, and that product equal to the product of its diagonals, that is to say it equals to X times Y, or the product of its diagonals, that is actually X times Y, equals to the sum of the products of its opposite sides, that is actually BD plus AC. And we actually can implement rule number 3 in our drawing. And first of all, why we can implement rule number 3 in our drawing? Because in our drawing we have quadrilateral ABD that is described by a blue circle. Whenever you have quadrilateral that is described by a circle, you can implement rule number 3. And we have here quadrilateral that is described by a circle, therefore we can implement rule number 3 in this drawing. And according to rule number 3, the product of quadrilateral AEBD diagonals is AB times DE. AB times DE is the product of its diagonals, and it equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides, the first product of its opposite sides is AE times DB. And the second product of its opposite sides is AD times EB. And the sum of the products of its opposite sides is product 1 plus product 2, or AE times DB plus AD times EB. And that sum of the product of its opposite sides equals to the product of its diagonals, that is actually AB times DE. Again, the product of its diagonals, that is actually AB times DE, equals to the sum of the products of its opposite sides, equals to AE times DB plus AD times EB. Okay, that is actually the implementation of question number 3 is the implementation of rule number 3 in our drawing. Okay, so the only thing that is left to do is to put the data inside this equation number 3. We know that AB equals to square root of 34 units, DE equals to 8 units. It is given us the question. AE is a missing line segment, so we will leave it as it is. DB equals to the square root of 68, AD equals to the square root of 34, and BE equals to 2 units. It is given us the question. So here 68 is 34 times 2, so we substitute 68 by 34 times 2, and the other variables are remain as they are. And we have the rule that the square root of A times B equals to the square root of A times square root of B, so we can say that the square root of 34 times 2 equals to the square root of 34 times square root of 2. Okay? Then we divided the equation number 3 by square root of 34, and that is what is left after we cancelled 34. We subtracted from this equation number 3 2. 2 minus 8 minus 2 is 6, so 6 equals to square root of 2 times AE, and AE equals to 6 over square root of 2. We know that 6 equals to 3 times 2, so AE equals to 3 times 2 over square root of 2. We multiplied this expression by square root of 2, and then we divided it by square root of 2, so we changed nothing, so it is allowable to do it. We got this expression. So here square root of 2 times square root of 2 is 2. So we got here this equation number 3 that says that AE equals to 3 times 2 times square root of 2 over 2. 2 over 2 is 1, so 2 will get cancelled. And we found out that AE equals to either 3 times root 3 units or 4.243 units. So I'll repeat again. The size of line segment AE, this line segment in the red color, equals to either 3 times square root of 2 units, 3 times square root of 2 units, or in terms of numbers, the size of line segment AE is 4.243 units. Okay? I'll repeat again. The size of line segment AE equals to either 3 times square root of 2 units, or in terms of numbers, the size of line segment AE equals to 4.243 units. Okay, thank you very much.